Another interesting problem on magnetic induction. This time I am taking a beautiful problem where we do a 3D picturization. The problem is on the combination of straight elements and curved elements. So here you are. First of all, let me spell out the x, y and z axis. This time I am taking this to be y, this to be z, and towards you is x. So x, y horizontal plane, and this z right-handed coordination. The first element is a long wire carrying current I, and the current is flowing inwards, that is along minus I cap. Then it turns in a 3/4 of a circle of radius r, and then in the yz plane, now this was y, this was z, then in the yz plane it goes out at an angle making 45 degrees as shown, long wire shown, the current. We have to find the magnetic induction at the point O. So once again we break it up into 3 elements. So BO arrow is B1 arrow plus B2 arrow plus B3 arrow. For B1 arrow, long wire and the point O is at the end of the wire, magnitude mu naught I by 4 pi r, and the direction, of course, if the current is flowing inwards, so O, that is down is minus k cap, tangent to the curve, so minus k cap. For the 3/4 of the circle, mu naught I by 2 r, full circle, multiplied by 3/4, the fraction, and then of course for this thumb is inside, so the field is, direction is minus I cap, in the board minus I cap. B3 arrow we'll do separately because that would need some more rigorous understanding. I do it separately for you. Now the third element, now what is the third element? Look at that. This was y, this was z, and somewhere here, the wire somewhere here, this point is O, it is going long wire at an angle of 45 degrees as shown, long wire. Now for the long wire, I just extend it backward, I do this, show it on a bigger picture here. So this distance is A, so this is the long wire now, but this part is not there. The element starts from here, so this is the extra part. Perpendicular from O, that distance is A. Of course, from here to here is R, here to here is R. All right. This is not required. I can remove this. It's not needed. So I can say now, from the point O, I join the extremities of the long wire, then this angle is 45 alpha. Well, the concept is of course mu naught I by 4 pi A. A is the perpendicular distance from the point O on the wire into sine alpha plus sine beta, where alpha and beta are the angles when I join the ends, extremities of the wire from the point O. So this angle is 45, that is alpha, and the other is 90, but this part of the element is missing. So I would have to take this alpha to be as minus 45 degrees. Be very careful. This part of the element was not there. So forget this. So it is minus 45 degrees. That contribution has to be removed. And of course, beta is 90 degrees. I put down the values. And as far as the direction of the field is concerned, well, the current is like this. So, well, it is outside. Because if the current lies in the YZ plane, the field at O will have to be perpendicular to the plane. And of course, the current is going outwards. So it will be I cap, positive X. Fine. So B3 will be mu naught I upon 4 pi A. I break A as R by root 2 because A is R cos 45 degrees. So A is R by root 2. I replace that here A, and sine alpha is minus 45 gives me minus 1 by root 2. and then sine beta 90 degrees, beta is 90 degrees, that gives me 1, the direction is I cap. Now I collect this I cap along with this minus I cap, this part, and if I take I cap outside, then this whole part will be taken as minus. I take the common mu naught I by 4 pi r. So mu naught I by 4 pi r is common. So inside I'll get this part, that is root 2 minus 1, and this whole thing I multiply and divide by pi. So I'll get 3 pi by 2 minus. So fine. For the element 1, for the element 2 and the element 3, I am getting mu naught I by 4 pi r into root 2 minus 1 minus 3 pi by 2 I cap. And of course, for the 1 we have minus k cap. So mu naught I by 4 pi r minus k cap. And this gives me the final answer. Of course, if you have to find the magnitude, then the final BO arrow lies in the x and minus z plane. The magnitude will be square of all that, sum, and then square root. Well, that is just a mathematical process that can be done. But once the vector is given in the compo form, well, it's accepted as the answer. So with this, you have learned a good problem on magnetic induction.
If you love the video and want me to make more useful videos for you, subscribe my channel and hit the bell icon to stay updated.